Okay, so welcome to our RCPS methods workshop this morning. I will be starting with the land acknowledgement, and then after that, I will introduce the two speakers who are going to be speaking to this about these methods this morning. And also to just let you know again, for those of you who've just joined us, that we are recording this session. My name is Sylvia Bawa. I'm an associate professor here at York University in the Sociology department, and I'm the director for the Resource Center for Public Sociology. You would have also received emails and registration information from Susan Foster, whom we call Sue, who has been fantastic at really making sure that all these kinds of things run seamlessly. We also want to note that Dr. Dugai, who was supposed to be speaking today, will not be able to join us for some reason. And because of that, we were able, thanks to Muyang, to get a replacement speaker at this very last minute and at a very busy time of year, who also agreed to join us this morning. So I will be starting with the land acknowledgement now. York University recognizes that many indigenous nations have long-standing relationships with the territories upon which York University campuses are located that precede the establishment of the university. York University acknowledges its presence on the traditional territory of many indigenous nations. The area known as the Karanto has been caretaken by the Anishinaabe Nation, the Haudenosaunee Confederacy, and the Huron-Wendat. It is now home to many First Nation, Inuit, and Métis communities. We acknowledge the current treaty holders, the Mississaugas of the Credit First Nation. This territory is subject of the Dish with One Spoon, One Pond Covenant Belt, an agreement to peaceably share and care for the Great Lakes region. Now, Professor Zhifan Liu from the Department of Sociology and Anthropology at Concordia University is an assistant professor in that department. And her research and teaching integrate computer-assisted content analysis with traditional qualitative and quantitative methods to investigate the dynamics of power and resistance in the authoritarian and democratic context. In an ongoing project, for instance, she theorizes legitimation of censorship as a social process. Her work has appeared in New Media and Society, Information, Communication and Society, the Sage Handbook of Social Media Research Methods, the second edition, China, an international journal, among others. And today she's going to be discussing with us analyzing digital text. I will now give the floor to Zhifan Liu to take us through this topic.
Thanks to Sylvia for introducing me, and let me share my screen first. Can people see my slide?
Yes.
Okay, great. First, thanks so much to Sylvia and Susan for organizing this workshop, and thanks to Muyang for inviting me. As introduced, my name is Zhifan Liu, and I'm assistant professor of sociology at Concordia. In the following 30 minutes or so, I will briefly talk about analyzing digital text using a computational approach, or what we call as computer-assisted content analysis. I hope I can give you an accessible and smooth start to this method, assuming most of you are not familiar with it in the first place. And today, when people talk about computational methods or algorithm or artificial intelligence, the first thing that may come to our minds is generative AI like ChatGPT. Well, today, ChatGPT seems to be like on everybody's mind, and every profession is worried about its job being replaced by ChatGPT or other AI. For example, a group of researchers at Northwestern University and the University of Chicago found that it is difficult for human reviewers to tell the difference between medical abstracts generated by ChatGPT and roles returned by human authors. And a scholar at Stanford University conducted a series of mind tests on multiple large language models. He found that models before 2022 show absolutely no ability to pass this test. However, later model, particularly GPT-3, which is an earlier version of the model behind ChatGPT, was able to solve 30% of the tasks. And the more advanced version can solve over 90%, which is equivalent to the performance of a 9-year-old child. It means that large language model like GPT 3.5 can perform some functions of the human mind, which is used to distinguish human beings from other beings. And such examples can go on and on. ChatGPT is able to pass Google's interview and recruitment process and can be hired as an entry-level engineer. It's also able to pass MBA exam at one of the most elite MBA programs in the world. These are all amazing things that ChatGPT is able to do, and the whole world is at war. However, if I ask ChatGPT a math question, to save the time, I did the experiment in advance. I input 2 random numbers and ask ChatGPT to calculate the sum of these 2 numbers. And this is the answer from ChatGPT. To verify this answer, I open the simple calculator and input these 2 numbers. And this is the answer from my calculator. If we compare these 2 underlined numbers, they are different. ChatGPT gave us 90346, 231603. And my calculator gave us 90345, which is the same, but 931603. So they are different. And we know the calculator can be our golden standard here, which means that the savvy ChatGPT cannot beat a calculator when it comes to a simple mathematical question. But how can we make sense of it? Before I try to answer the question here, let's see how ChatGPT itself may make sense of similar question about its own capacity. This is an interview between a human interviewer and ChatGPT, and let's watch just a clip of it. Let's start here.
Are you fair and balanced?
As a large language model trained by OpenAI, I do not have personal beliefs or opinions, and I am not capable of making judgments or decisions. I am a machine learning model that has been trained to generate human-like text based on the input I receive. My responses are based solely on the data that has been provided to me during my training, and I do not have the ability to be fair or balanced in the way that a person might. My purpose is to assist with tasks such as answering questions and providing information, not to make judgments or decisions.
Are your answers influenced by what your creator's biases are?
As a machine learning model, my responses are not influenced by the personal biases of my creators. I am trained on a large dataset of text, and my responses are generated based on that data and the input I receive. I do not have personal beliefs or opinions, and I do not make judgments or decisions. My purpose is to assist with tasks such as answering questions and providing information, and my responses are intended to be factual and accurate.
Let's try a sort of tabloid talk radio question. What is a woman?
A woman is an adult human female. Women are distinguished from men by their biological characteristics, such as their reproductive organs and the hormones they produce. In general, women are typically considered to be the female members of a species, while men are considered to be the male members. Women have unique experiences and perspectives that are shaped by their biology and by the social, cultural, and political environments in which they live.
Is a trans woman a woman?
Yes, a trans woman is a woman. A trans woman is a person who was assigned male at birth, but who identifies as a woman. Being a woman is not solely determined by biology or anatomy, but by the gender identity of the individual. A trans woman is a person who identifies as a woman and should be respected and treated as such. It is important to recognize and validate the gender identity of all individuals, including trans women.
Are you a bit...
Well, the interview goes on, but we will stop here. In the clip that we just watched, ChatGPT claims that it does not have personal beliefs and opinion, and it cannot make judgment. And its response is solely based on the training data fed into the model. There are a lot to discuss here, but for the purpose of our workshop today, I will just focus on one thing. Here, I want to draw your attention to the fact that it repeatedly comes up in the interview that ChatGPT refers to itself as a large language model. This is interesting and relevant to my talk today because we may know little about AI, but we all know something about human language. We know language is the media of expression and interpersonal communication. It may not be accurate in the mathematics sense, but it can be accurate to convey our feelings, our attitudes, our values. If ChatGPT was trained based on large corpus of human language, then its strengths and limitations are also determined by the strengths and limitations of human language. For ChatGPT and other generative AI, they care about, or their creators care about, what can be generated from language, from large language model. For what we talk about here, about analyzing digital text, we care about a similar question. What can we extract from language as data? What can we extract from language? Of course, the answer to that question depends on what elements are contained in language in the first place. Well, content, of course, whether factual or not, depending on the relationship between a text and the reality, rather than the language itself. But of course, language contains content, and it is something we may extract from language. But besides content, also style, like the writing style, whether the author used passive tone a lot, whether use long sentences rather than short ones. Also feelings, emotions. Even though ChatGPT repeatedly said it does not have personal feelings or emotions, we know that language can be a container or carrier of feelings and emotions. And we as researchers can extract that from a corpus. And culture and value systems. It's clear from the interview that ChatGPT's response contains social values. We all know that language is important to the spread reproduction of a culture and value system. And that's something we can extract from language as well. And also social relations and social structure. The relationship between people of different genders, different culture and racial background, we can find that in language as well. And that's exactly the reason why public speech on social media or other occasions became salient in the cultural wars. Behind this language of social relations, we can see a larger social structure of inequality, and that is something contained in the language. So if language can contain such rich data, if we can see language as data in this regard, the next step is to think about what tools we can use to extract that, this data from a corpus. And here is where computational methods can come in handy. First, to extract content, for example, we can use topic modeling. To extract the style, I can use part of speech analysis. For feelings and emotions, maybe use sentiment analysis. For culture and value system, moral foundation analysis is one option. And for social relations and social structures, maybe word embedding. You don't need to worry about it if you don't know any of these methods, and I just want to give you a sense of what kind of methods is available here. And this is definitely not an exhaustive list, and I do not intend to be exhaustive today. Instead, I would just want to show you some examples of how computer-assisted text analysis can be used to answer social scientific questions. So in the next step, I will highlight two methods used in a study of mine, topic modeling and moral foundation analysis. I want to show you how they can be put into a real analysis to answer real social science questions. As we just mentioned in the last slide, the goal of topic modeling is to extract the information about the content or topics from a large corpus. Then how does the topic model extract the topic? Let me, at the risk of some oversimplification, let me try to explain to you how does the algorithm of topic modeling works. The assumption of a topic model is that each topic is composed of words. If some words always occur in the same documents, then they probably belong to the same topic. That's the assumption. And each document is a mixture of these topics represented by these different words. So what does that mean? For example, in the document titled Seeking Lifespan Genetic Necessities, all the words in this document belong to different topics. The first topic is composed of words such as gene, DNA, and genetics. Then the topic is probably something about gene technology. And the second topic is composed of words such as life, evolvement, and organism. Then the topic is probably something about life science, so on and so forth. So based on the assumption that each topic is composed of words and each document contains these different topics, we can use statistical model to calculate the likelihood of a group of words belonging to the same topic. And this statistical model is topic model. When you fit a topic model to a large corpus, for example, millions of tweets you've collected, you can get some visualization like this. First, you get some top words that are most likely come together to form a topic. Second, based on this calculation, you get an estimation of the proportion of each topic in the corpus. Let me show you how we can put that into use. This example is from a paper that I published years ago. The context of this study is the Capitol riot happened on January 6, 2021 in the States. Following the riot, Facebook, along with other social media companies, took action to restrict Donald Trump's access to their platforms. Facebook per se, it placed a ban on Trump's official account on Facebook and Instagram. As you know, a Trump ban like this can become controversial in a highly polarized political context in which neither side trusted the other. And you can imagine like the pushbacks against such a ban on the ground of like free speech or due process. That's the reason why Facebook decided to hand over the case to its oversight board, which is composed of external board members that Facebook handpicked and believed they have the authority and right knowledge to advise Facebook regarding its regulation of content. For the case of the Trump ban, this board called for input from public opinion, and it later released the public opinion that they've received, the public comments they received, along with the board's own decision. In this study, I collected all the public opinion comments submitted to the oversight board regarding Facebook's Trump ban. And I'm interested in the value system underneath the arguments made for or against the Trump ban. More specifically, the first research question I asked in that study is what reasonings are provided to argue for or against deplatforming Trump. To do this, I ran a topic model with 15 topics based on all the public comments submissions. And this is the results I got from this model. It identified 15 topics for me. And after reading each topic, I found 2 of them are just a linguistic noise, which is common in a topic model. So I deleted them and retained the remaining 13 topics. What I got from the model are these most probable words for each topic. Then I labeled these topics to identify what each topic is about. I also calculated the proportion of the content or words that support or oppose the Trump ban. So this table helped me describe arguments made by both sides, and it also helped quantify the stance for and against the ban. So basically helped me answer the first research question. And this is an application of topic model. The second case I want to show here is moral foundation analysis. Topic modeling is actually a machine learning technique. More specifically, it's unsupervised machine learning, which means that the machine or the topic modeling algorithm is asked to find patterns by itself. Indeed, ChatGPT is also developed through unsupervised machine learning. But moral foundation analysis represents a different approach. It's dictionary-based automatic content analysis. The idea here is that we can treat a document as a bag of words. When we have multiple bags of words, we can compare them by looking at the words in each bag. For example, when maybe we are interested in whether one document is more positive than the other, then we can calculate the number of positive words in each bag and compare these numbers. And to do that automatically, we need a dictionary of all the positive words in a language, for example, English. We can provide the algorithm with the dictionary and ask it to calculate the number for us. And this is the basics for the dictionary-based approach. And the moral foundation analysis uses the dictionary-based approach. The theory under the analysis here is that human beings' moral system is composed of 6 foundations: the care foundation, fairness foundation, the loyalty foundation, the authority foundation, the sanctity foundation, and the liberty foundation. If we can identify all words associated with each foundation in a language, then we will have a dictionary for each moral foundation. And we can automatically analyze moral foundations in any text of that language. And I apply this analysis in my Facebook project to answer the second research question: do different camps rely on different moral foundations to make its argument? Here is a screenshot of the interface with the output. Each row here represents a text document submitted to the oversight board. You can see the body of the text and the number of each moral foundation for each document. This number represents the number of words belonging to a moral foundation in this document. And with this number, with this proportion of different topics in each document, I can use quantitative methods to estimate their correlation and therefore answer the second research question: do different camps rely on different moral foundations? And this is the output table in the paper. Just for example, we can see those who support the Trump ban. Their arguments are positively associated with the care foundation, which means that they are more likely to make an argument based on caring for others, caring for the country, and caring for democracy. While those who oppose the Trump ban, their arguments are negatively associated with the care foundation. Instead, they are more likely to use other moral foundations like fairness, whether the process of deplatforming Trump was fair or not, the loyalty foundation, the authority foundation. As a result, I draw the conclusion that different camps rely on different moral foundations to make their judgments. They are different not only in the sense of opinion and stance, they are also different in the sense of which moral foundation they prioritize. So this is one example of how we can use dictionary-based automatic content analysis to analyze a social event and answer a social science question. So far, I hope I have convinced some of you that computational methods can be helpful to analyze digital text. Now, if you have become interested, there are something to bear in mind as well. First, computer-assisted content analysis is first developed by computer scientists for natural language processing. In their field, they are more concerned with solving a specific tasks, such as identifying spam emails. This is very different from us as social scientists. Our research is not just to identify a pattern, but we want to answer a research question. Therefore, before you want to apply a computational method to a digital text database you collected, take a break and think about what's your puzzle. What question do you intend to answer? Is the method suitable to answer your question? Then, when you get the puzzle, get a research question, and ascertain that the method is suitable, the next thing is to take a close look at the data set you collect. In machine learning, there's a famous saying, garbage in, garbage out, which means that if you feed data of poor quality, of a lot of noise into a model, you will only get noise as output, no matter how much data you feed, no matter how advanced your model is. This is the limitation of any large language model, as well as other computational models. Third, verification, verification, verification. So no matter what you fit into a model, it will generate some output for you, but it does not mean that the output is valid. To take topic modeling as an example, you can decide to have only 2 topics, or you can decide to have 20. Either way, the model will give you the result. But it doesn't mean you should trust the 2 topic results or the 20 topic results. Instead, you should verify these results to determine what topic number is most appropriate. Maybe neither of them is the appropriate number. It's the same for any methods of computer-assisted content analysis. So verification, verification, verification here. And when we deal with large corpus in the digital age, we kind of enter the area of big data, which has its own ethical challenges. We don't have time to get into that topic today, but I still want to put it here. For my Facebook project, the data I collected are publicly available. Those who submitted their opinion to the oversight committee can choose whether to have their comments published or not. And what I accessed are only those published one, of course. But if you intend to use comments made in non-public platforms like a private Facebook group, there could be an ethical problem. So before collecting any digital data, think about the ethical indication first. Also, I want to highlight one point here. One myth of computational methods is that the methods are objective. No, that's not true. Computational methods are not objective. Instead, every step of the analysis involves some human decisions. And that's the reason why we are not seeking objectivity in computational methods. Instead, we seek transparency regarding what human decisions have been made and why a particular decision was made this way. And this also applies to our thinking of algorithm and artificial intelligence today. Now, you may begin to think about learning these methods, but it also could seem very horrifying for you if you have never coded before. In other words, there might be a psychological hurdle of learning computational methods. And I totally understand it because I've been there. But I want to say that code is just a new language. It's computer's language. Although experience, through our experience and endurance, most people can make it. Not to mention the fact that ChatGPT can come in handy to help you write code or debug the codes you write today. You may imagine writing codes as starting from scratch every time for a new project, but that's actually not the case. What most people do when they write codes, they just adjust the code returned and shared by others to their own projects. Or sometimes we can write really ugly codes. And that's also totally fine. As long as it works, there's no shame on it at all. It's not to say that learning computational methods or learning how to code is easy for students of social science. It also took me a while to crack topic modeling, to be able to extract all the information I need from that topic model. there is a steep learning curve, but at the same time, it's not as hard as you may imagine. And the method I've mentioned have been widely applied in sociology, psychology, communication, political science, and other fields as well. So I hope my talk today serves as a starting point for you to think about digital data as text that can be analyzed with the help of computer. Thanks for your attention, and I'm happy to answer any question in the Q&A session.
Thank you so much, Zhifan, for that, and for the reminder that we should be proud of ugly codes for those who write ugly codes. I guess, especially if you're also making a new recipe for the first time, be proud of it, no matter how it comes. Thank you so much. That was very informative. It is now my pleasure to introduce to you our second speaker for the day, my colleague here in the Department of Sociology, Muyang, who is also responsible really for organizing this particular session. So thank you so much, Muyang. She's an assistant professor here in the Sociology department. Her research is organized around the key question: how does media interact with democracy and social life? Her research involves digital technology, authoritarianism, public sphere, and gender issues. With an interdisciplinary background in sociology, computational social science, and communication, she uses mixed methods that combine qualitative, computational, and statistical methods in her research. Her research has been published in New Media and Society, Information, Communication and Society, the Sage Handbook of Social Media Research Methods, and other outlets. She's a faculty fellow at the Center for Cultural Sociology at Yale University and a faculty associate at York Center for Asian Research. Take us away now, Muyang. Thank you so much.
Thank you, Sylvia, for the introduction. So I'm going to share my slide. Okay, can you see that?
Yes.
Okay, great. Let's see. Okay, hello everyone. Thanks for coming to this workshop on digital methods during the final weeks. As you know, my name is Muyang Li, and I'm kind of specialized in digital sociology. And it's no surprise that I use some digital methods, including the text mining methods, which has been introduced by Zhifan. So for my talk, I will introduce you to the potential of combining computational methods with other methodological approaches. So before we start, I want to learn what research methods you use. Okay, so could you please raise your hand if you use or plan to use qualitative methods? Okay. Wow, I will see most of you. Okay, so hands down, please. Could you raise your hand if you use or plan to use quantitative methods? Okay, not as many as the colleague guys, but there are some. You can put down your hand. And has anyone ever tried mixed methods? Raise your hand, please. I can raise my hand. Okay, great. Not bad. Actually, the number is larger than I expected. Okay, so yeah, so when I was at your stage, when I was a graduate student, I relied on qualitative research methods. And when I consider if I should invest my time in learning computational methods, which usually take at least 1 semester to master the basic skills and potentially more time to tailor this method to a specific study. That's a lot of time investment. At that time, I want to know if it deserves my time, especially when I already have methodological skill sets. So at that time, I asked around and seek answers to questions like, how can computational methods be applied to my research? Can they be combined with other methods that I'm specialized in? So the goal of today's talk is to provide answers to these questions. I will demonstrate the potential of using computational text analysis in empirical studies, reflect on its advantages and disadvantages, and introduce you to some valuable resources if you wish to dive deeper into this field. Please note that this session will not include any hands-on activities. As I mentioned, it usually takes months to master the basic skills of computational methods, and I don't expect to do that within 30 minutes. So today is mainly about the demonstration of the potential of this method, especially how we can combine computational methods with the methods you already mastered. Okay, as we know that the rise of big data and the computational methods has led to an increase in academic publications employing these techniques. These methods pose significant challenges to researchers, particularly those who traditionally rely on qualitative approaches for text analysis. So if you can analyze an entire population of text, what is the point of selecting a few and presenting them as representative? This leads us to ask, is qualitative text analysis dead? Do we still need human coders for content analysis? So qualitative researchers, how would you defend yourself or your approach in the digital age? So I would say qualitative text analysis is far from that. In fact, it plays a crucial role in text analysis, complementing and enhancing computational approaches. As researchers for content analysis, no matter what method you use, you need to know your data. The best research results come when researchers deeply understanding their data. This requires human coders to read and interpret the text, ensuring a comprehensive understanding of the material. Although computer-assisted text analysis is very powerful, its performance in detecting complex, contextual, nuanced, or subtle expressions is still inferior to human coders. And the third reason that qualitative text analysis is still vibrant is that computational methods are not fully automatic. As Zhifan, Dr. Luo mentioned, it requires human coders to validate their results. It requires human coders to make decisions. Automated text analysis can be biased or incorrect. Human coders play a vital role in validating the results and ensuring accuracy and reliability of the whole process. So we acknowledge the benefits of using computational methods to analyze big data. These advantages include time efficiency, reliability, and reproducibility, and the ability to systematically process and analyze vast amounts of data. However, we also recognize that computational methods are not always superior to qualitative analysis. So here is a comparison between the computational text analysis and qualitative text analysis. On the one hand, traditional qualitative text analysis has numerous advantages that cannot be replaced by computational methods. This includes the ability to extract complex meanings from text, the use of human coders as the gold standard, and the incorporation of expert substantive knowledge. So instead of debating which method is superior or choose one over the other, we propose exploring ways to combine the different approaches to maximize the benefits of each. So this fusion of methods, or we call it a mixed method approach, can lead to more accurate and insightful analysis, ultimately allowing researchers to better understand and interpret the wealth of textual data. So today, I introduce the mixed methods computational approach, which combines computational methods with narrative analysis, survey, and statistical inference. This powerful approach offers numerous advantages over relying on a single method alone. So in the following session, I will present 3 case studies that demonstrate the power of combining computational methods with traditional methodological approaches. These examples will showcase how the mixed methods approach can significantly improve research outcomes and drive new insights across diverse areas of study. Okay, so as a qualitative researcher, incorporating computational methods into your research can enable your study, enable you to study large data sets while still being able to focus on the details of a smaller subset within a specific topic. So one such technique is text mining, which involves extracting valuable information from unstructured text data, allowing researchers to efficiently find a needle in a haystack. To illustrate that, let's consider a study that sought to answer the question, does social media contribute to promoting gender equality, or does it intensify gender discrimination? To tackle this question, the researchers, that is Dr. Luo and me, collected social media discussions and newspaper reports on traffic accidents in China, which aim to evaluating how different these reports were in covering male and female drivers involved in the accident. Specifically, we want to examine the application of sexist discourse when describing female drivers involved in the traffic accident. So for this study, if I remember correctly, we collected more than 97,000 of microblog posts and more than 11,000 newspaper articles. And this number makes manual coding unrealistic. We cannot rely on human coders to do everything. Well, it was possible to create a keyword list to identify and extract relevant data. This approach may overlook specific expressions and might be unfamiliar or infrequently used. So as a result, we use computational methods to help identify relevant data. And the specific method we use is topic modeling, which already been covered by Dr. Luo. And we were able to uncover 35 distinct topics within the data. As shown in the diagram, you can see here. So in this picture, each black dot represents a topic, which is a cluster of text corpus sharing the same theme. So by examining these topics, we identified a cluster of sexist language, successfully identifying the needle in the haystack. That's what we are looking for. Additionally, we discovered that this topic was more prevalent on social media. So you can see on the left is newspaper, on the right is is the Chinese social media. It's called Weibo, and there's a line in the middle. So the topic of sexism falls into the spectrum on the right, so that is more relevant to social media. So here we may conclude that social media is more likely to intensify gender discrimination compared to newspaper, because sexist language is more popular on social media. However, rather than stopping there, we introduced qualitative analysis to deepen our thoughts or understanding of the media of the data on this topic. So we conducted a thematic analysis on the 900 identified articles. This is a small data set, not well suited for computational methods. So here's the results. We found that there are competing themes under this topic. The feminist discourse competes with the sexist discourse. And as you can see, like for the first category, which represents more than half of the posts, more than half of the posts involving sexist discourse this post using the sexist discourse are actually against the sexist argument, directly addressing sexism or claiming female drivers are not inferior to male drivers. And only 10%, category 2, only 10% of the posts using sexist language really try to justify the sexist argument. So based on these standings, we concluded that Chinese social media serves as a platform for gender-aware discussion, where feminist discourses compete with sexist ones, ultimately possessing the potential to promote gender equality. So this case study demonstrates the power of integrating computational and qualitative methods, enabling researchers, us, to analyze large data sets will be able to zoom into the nuanced details that are crucial for understanding complex social phenomena. In recent years, many researchers argue that computational methods, such as topic modeling, can serve as powerful quantitative tools for qualitative approaches. There are several key benefits of using these methods together. Well, qualitative analysis offers an in-depth view of content. It is sometimes criticized for being too narrow and relying on small data samples. Topic modeling and other computational methods allow researchers to examine entire data sets and identify prevalent themes, providing a broader perspective. For instance, in our study, we are able to examine all 35 topics. That ensures that we don't miss any significant or interesting insights. Next, computational techniques such as topic modeling can act as a starting point for qualitative researchers to focus on their analysis. By generating a list of topics and associated terms, researchers can dive deeper into the data, examining patterns and the nuances within the identified topic and exploring their connections to broader discourses. Again, back to our case, we can visualize the entire universe of the data through the 35 topics, while also zoom into this specific one. So this mixed method approach enables us to achieve both depth and breadth in content analysis. Last but not least, a mixed methods approach can help enhance the transparency and the reproducibility of qualitative methods. Qualitative coding is often criticized for being subjective, lacking of transparency, and being difficult to replicate. Topic modeling results, on the other hand, can be easily shared and reproduced. For example, researchers who are interested in our study can request our programming scripts and replicate the analysis by themselves, or they can build on their own research based on our code. For researchers who use qualitative approaches to work with large corpus of text data, such as field notes, interview records, or media content, adding computational methods to your toolbox can significantly enhance the overall quality of your research. So next, let's discuss computational methods' potential in combining with surveys to answer difficult research questions, like this one: how to identify fabricated or coordinated inauthentic social media posts. If you have ever used social media, I guess all of you do, you are likely aware of the prevalence of inauthentic content. Such content is intentionally created and disseminated on social media platforms with the aim of manipulating public opinion, spreading disinformation, or promoting specific narratives. These posts often involve the use of fake accounts, bots, or paid human users. Do you have any idea in identifying this fabricated social media content? You will be able to identify some posts with your instinct. You'll say, okay, this account must be fake because of some reason. But how would you design research to answer this question? How can you answer this question in a scientific way? Some top scholars have taken on this challenge of identifying fabricated social media posts sent by Chinese governments. In China, propaganda officials often conceal their true identity, posting as ordinary citizens to manipulate public opinion and control information flow. They typically follow the authorities' guidelines, and in the year of 2014, a leak exposed more than 43,000 fabricated social media posts and thousands of accounts responsible for sending these messages. This leak served as the starting point for this innovative study. So, to make the best use of this data, the leak, researchers employed computational methods to identify patterns in the content, connections between these kind of fake accounts, and features of their coordinated behaviors. Well, most studies might have stopped at this point and present what they found, present the patterns from all these leaked documents or posts. But the authors of this study took it a step further. Based on their findings from text mining and network analysis, they built a model that predicts whether a social media user is an undercover official and tested it through a direct survey. So this study is on social media. And as users of social media, you know that you can send direct messages to anyone as long as they don't block you. So the authors of this study, they choose to send direct messages to these suspected fake users and ask them whether they are undercover officials. Of course, you cannot ask it directly, but the researchers carefully choose the word in the survey question. So they send a direct message saying, I saw your comments, it's really inspiring. I want to ask, do you have any public opinion guidance management or online commentating experience? So this language, the public opinion guidance management, is the kind of official language used by the Chinese government to describe this officially support commentation or social media engagement behaviors. It's kind of positive or at least neutral. So they try to use this message to poke those users and see if they can receive a response. Of course, they need to obtain research ethics approval before sending these messages. So the researchers sent this message to 3 groups of accounts: confirmed undercover officials accounts, suspected undercover officials accounts, and non-official regular users accounts. The response showed that the confirmed official accounts and the suspected group had strikingly similar responses. For both groups, there are nearly 60% of users confirmed that they have been trained as an official commentator. So these results validated the findings from the computational analysis. So, all right, Now that we know the Chinese government has deployed a lot of officials for online propaganda, we may ask, how does Chinese authorities' social media engagements influence public discourse? And I will answer this question by introducing another case study which combines computational methods with statistical inference. So to answer this question, how does the government's social media engagement influence public discourse? We need to break down this question. We need to be more specific about influence. How can we evaluate the impact generated by the authority on the public discourse? One approach is to compare the official propaganda discourse with social media posts sent by regular users and examine if the latter become more similar to the former over time. If the answer is yes, we may conclude that the public's discourse is mirroring the official narrative. However, this introduces another question. How can we measure content similarity? For humans, this task is relatively easy. So consider these two sentences. Obama speaks to the media in Illinois, and the president greets the press in Chicago. Well, these sentences share no similar words. They convey nearly identical information. If we had a few hundred sentences like this, a human coder could evaluate their similarity manually. It's easy to tell that they are same. Their meaning are almost the same. But what if we have millions of documents like this? How can we compare their meanings? This is where computational methods come into play. By using techniques such as cosine similarity or more advanced neutral language processing tools like word embeddings, we can identify the similarities between large sizes of documents, even when their surface level wording differs. This technique helps compare content similarity based on semantic representation by converting words into numeric vectors. And in that way, they can capture their contextual meaning. So in this case, the two documents I showed you before, Obama speaks to the media in Illinois and the president greets the press in Chicago. They will be first converted to a numeric vector that reflects the semantic representation of words contained. And these vectors are compared to see how far they are from each other. In this case, these words are pretty close in their meanings. And you can see, like, when once compared to converted to vector, Obama is close to president, so do press to media. The calculation result considers these two sentences are close in meaning. This is the computational approach to compare meanings. Powered by this technique, I can compare meanings of Chinese microblog posts sent by regular users with the official propaganda messages, using their level of content similarity as the dependent variable to fit a linear regression model. So the independent variables are Chinese official social media engagement, such as the posts and the likes received. So what I found is that the official's online engagements predicts content similarity. The more posts the official posts receive, the more likely the public will copy the official discourse. Therefore, Chinese authorities can actively shape the online discourse through social media engagement. In this case, you can tell that computational methods serve as a bridge between the qualitative and the quantitative content analysis by combining the strength of both approaches. They enable researchers to process and analyze large volume of textual data efficiently while still considering the context and meaning behind the text. Before we head to the end, I want to introduce a digital tool that can be useful for those who study content in multiple languages, machine translation. Of course, this can be combined with any analytical methods. We know that computer doesn't speak human language, and they rely on programs. To interpret and translate language, machines rely on two popular approaches: phrase-based translation and neural machine translation. The phrase-based translation is a machine translation technique that breaks down source corpus into smaller linguistic units. And here is the phrase and translation, each of these phrases individually. So this approach is quite simple. However, it does not perform well for language pairs with big difference in word order. Another approach is through neural machine translation. Rather than pairing phrases in sequential order, neural machine translation converts language units into vectors, it's like word embedding, which represent their relationships with all other units. So every unit is embedded in a high-dimensional space in which their positions represent their relationship with the rest units. And this approach allows calculation of meanings, verb tense, and other relations in language or across languages. Once you input enough training data, the trained model will capture meaningful grammar and semantic regularities. For example, the distance between men and women are quite close to the difference between queen and king. So these two pairs of words are comparable, and this difference can be recognized by machine translation. And with advanced pre-trained language models, the computer can achieve more accurate machine translation. Many researchers suspect the accuracy of machine translation. They would rather do it by themselves or through hiring a human translator. So let's see how's the performance of machine translation compared to humans. The fact is, it performs pretty well for most used language. For English, Spanish, and English French translations, you can see showed in this chart, the performance of Google's neural machine translation is quite close to that of human translation. So you can see the bar on the top, the orange line represents human translation, and the green line, the upper bar of the green line, represents machine translation. And you can see they are quite close in these cases, though machine's performance is still inferior to human. So if you want to study in foreign languages instead of hiring a translator, you may consider subscribing to Google Translation API as a virtual research assistant. In most cases, the cost is much lower. So in this slide, I will introduce some valuable resources for those who are eager to explore more about digital methods. We will briefly discuss each resource and explain why they are useful for you to learn to your learning journey. So if you are still not sure about what digital methods can do in general, you may consider reading this book, Bit by Bit, Social Research in the Digital Age. So this is a comprehensive guide for social scientists who want to use powerful digital methods. It covers various topics, including experiments, surveys, data analysis, providing solid introduction to digital methods for social research. If you are interested in conducting a study on social media, I know many of you are very interested about that, but don't know where to start, you can refer to the Sage Handbook of Social Media Research Methods. So this is a book that focuses on practical aspects of conducting social media research. It covers various topics such as data collection, analysis, visualization, and ethics. And it also has chapters on specific social media platforms, including Facebook, Twitter, Instagram, YouTube, Reddit, and even TikTok. So it's a good book that provides beginners with step-by-step guidance, case studies, and examples. And at the last, if you want to have intense hands-on experience about to learn the digital methods, you should definitely consider attending the Summer Institute in Computational Social Science. So this is a 2-week-long summer school program initiated by sociologists to encourage interdisciplinary collaboration in the field of computational social science. And by the way, both speakers of today's workshop are alumni of this summer school program. And lastly, if you are interested in learning the research design in computational social science, the computational methods, or how to incorporate digital methods with your existing skill set, I will provide a course on it next fall semester. It's Soc 6090, text mining for social scientists. So we know that computational methods is broad in scope, and this course is focused on how to use text as data in social science research. It will provide an overview of various methods, from collecting to analyzing text data, to research ethics, or to mixed methods. So you will get some hands-on opportunities to practice skills and develop your own project. All right, so this is the end of my talk on the mixed method computational approach. Thank you.
Thank you so much, Muyang, for your talk as well, and for the resources you shared, particularly at the end. I'm really grateful for that. So I'll open the floor now for questions, answers, and discussions. So anyone who has a question, you can either put it in the chat or raise your hand, and I'll call on you to answer. I will just so I'll wait to see if there are any questions, for people. For Muyang and Zhifan.
Can I ask a question to Dr. Lo?
Yes, of course. Go ahead.
Okay, so we all know that Elon Musk has purchased Twitter. And I know that many researchers use Twitter as the data source for their study. Could you estimate how will that influence the kind of computational social science in general?
Yeah, I feel like first, I don't like it at all because we kind of enjoyed the free access for all Twitter data as Scholar in the past few years when the API is very accessible. But at the same time, we were talking about pushing ourselves out of the comfort zone and searching for alternative data, because Twitter is not the only social media. It's even not the most popular social media, and the data on Twitter can be highly biased if we use that to assume about everybody online, or even the general public in the States or in other countries. So first, I don't like it, and I don't thank Elon Musk for that. But at the same time, I feel like we finally have to think about other social media data and to think that seriously, like how to maybe combine not only Twitter data, but also Reddit and Facebook and TikTok, other alternatives, and the focus on image as data and video as data is also kind of on the agenda of computational social science right now. So I feel like, yeah, definitely I hate it, but the field is always developing, and we kind of have that mindset of what's the next game in town. So yeah, people need to think about that and to learn new techniques just to adapt to it. And at the same time, I feel like the academia should push the industry for making their data available to researchers who also kind of check on the so many important social issues using digital platform data. Yeah, that's my take.
Thank you.
Yeah, and thank you, Zhifan. Thank you for that, Zhifan. I'll be stopping the recording just because I know that we always obtain consent from our speakers to record, but we don't obtain consent from our audience to record their voices. So I'll stop the recording now for people who may, then perhaps feel more comfortable to speak to various questions.